Hello students. So today we are going to start your third unit. I have already included the topics which are included in your third unit with a PPT. So once again we'll glance the whatever the topics we are having in the third unit. The third unit is the name is solution of your first and second order networks. First and second order network. The solution of first and second order differential equations for series and parallel RL, RC, RLC circuits, initial and final conditions in network elements, forced and free response, time constants, steady state and transient state responses. So before going into the detail of your before starting your solution of your first and second order differential equations, first of all we need to know what is a order, when it is said to be a first order and when it is said to be a second order. Before to that we need to know, do we have any, here we have in this unit they have included some two types of responses, steady state response and transient response. So first of all we need to know what is the response. The response is nothing but simply it is the output which is obtained by applying certain input to the circuit. Already we have seen so many types of responses, like by applying DC voltage sources and AC voltage sources in first and second unit. So the response is nothing but simply it is a output which is obtained by giving some input to the circuit. So here we have given a name it of time response. When a response is said to be a time response, let us divide this time response into two words. Let us divide it into two words. Here you are having two words, that is of time and response. I have already said that this response is nothing but it is the output. Response is nothing but output. The time is nothing but your, it may be a seconds or milliseconds, microseconds, or which is a measured in seconds or anything. So if I include to the response one word, the time, that is called as time response. So what do you mean by time response? If the output or response of an electrical circuit for any input varies with respect to the time, then the response is called as time response. Basically, if you consider any circuit, if I apply input, if I apply input, here you are going to get output. Here the output depends upon your input. Here output depends on input. So till now we have seen in the first and second unit the dependency of your output on the input. Now in this unit we are going to see the dependency of your output on time. If output or response varies with respect to the time, or if response depends on time, then the related response is called as time response. Got my point? The response is a function of t. If I denote r is a response, then the time response becomes r of t. That is the difference. In time response we have two types of responses, steady state response and transient state response. Steady state and transient state response. We'll see what is transient state response. So before going to that, just see the waveform of a transient. This is called as, here this is a graph between something of output and your time. The C of t is nothing but output. So here you are having one curve which is divided into two subsections. They have given it as a transient response and the remaining is of steady state response. So this output is a combination of transient and steady state response. Then what do you mean by transient response? Let us define. A transient response is nothing but after applying an input to an electrical circuit, the output takes certain time to reach the steady state. So the output will be in the transient state till it goes to a steady state. Therefore, the response of an electrical circuit during the transient state is called as transient response. Transient response is nothing but it is a response which is obtained during the transient state is called as transient response. So when the transient response becomes 0, the steady state starts. In that steady state, you won't get any transient. So this is called as a transient response, and this is your, so this portion is called as steady state response. This portion is called as steady state response, which is obtained in steady state, and this response is called as transient state response. This response is called as transient response. So in this, whenever the input is applied, the output is taking some time. So this much of, for example, if I consider it is a time t1, so it is taking, the output is taking 0 to t1. That is it is taking a time t1 to reach the maximum value. Actually, it has to obtain the maximum value in the initial itself, but it is taking some time. That time is called as, that in that time the response is called as transient response. So whenever we analyze a response of a circuit with respect to the time, we may get this type of responses: transient response and steady state response. Now we are going to see presence and absence of transients. The transient occurs. Why this? Like we have considered that output contains transient response and steady state response. Why this transient response occurs? Because the transient occurs in the response due to sudden change in, due to, so why the transient occurs in the output? Due to sudden change in the sources that are applied to the circuit, or and due to switching actions. So remember, why transient occurs in the output? Because of two things. That is if you suddenly, if you change the output, if you change the input, that may be a voltage source or current source. If you change suddenly the sources, or that may be occurs, and or that may be occurs due to the switching actions. There are two possible switching actions, that is opening a switch and closing a switch. Because of these two things, the transient occurs in the response. What do you mean by steady state response? It is a part of the time response that that remains even after the transient response has become 0. Value for large values of t is known as the steady state response. 0 value for large values of t. For example, if you have considered here, this is called as steady state response. So when the transient response reaches to 0, then the steady state response starts and it remains constant. So the part of the time response that remains even after the transient response has become 0 value for large values of t is known as steady state response. Now we are going to see some time domain analysis. What do you mean by time domain analysis? The analysis of a circuit consisting of resistor, inductor, capacitor, voltage source, current source, switches, current source, voltage source, to sudden application of voltage and current is called as time domain analysis. So in the time domain analysis, we are going to see the analysis of a circuit, that is of the response of a circuit to the sudden application of voltage, current source. We are going to see how the circuit is responding, and with the circuit is having a switches. Let us see how the circuit will be when it is having a switches. We have seen this type of circuit. Something, for example, this is your voltage, and here you have connected one resistor, and here you are having some capacitor. This type of circuit we have seen in the last class. This is your resistor and this is your capacitor. So what do you mean by resistor? The resistor is indicated like this. The resistor is, that is up. Switch is indicated like this. If switch is closed, then only the voltage, the input voltage is fed to this branch. If switch is open, then this voltage source is removed from, we can call it as the voltage source is removed from the circuit. So like that. So with the help of switch, so we are going to feed the circuit with the input, or we are going to remove the circuit, that is input from the circuit. So in the next class we are going to see so the remaining topics in this time domain analysis.